Yes.
Right. So here we are. Yes. I'll start by sharing with you, what we do at the lab. The lab is at MIT, primarily in the main campus in Cambridge, Massachusetts. We tested the clicker before, but doesn't seem to work. Maybe something got disconnected. Yeah, it's good. So, but first of all, why are we passionate about cities? Well, if you want to remember 4 numbers about cities, just remember the one you see there, 255, 75, and 80. Cities are only 2% of the surface of the planet, but at 55% of the population, 75% of energy consumption, 80% of CO2 emissions. If we can do something to make our cities a bit more sustainable, well, that can be a big deal globally. And that is what we're passionate about. And today, in particular, we can look at interesting changes happening with technology. This is actually the logo of the lab, of our lab, Senseable City Lab, but it's about the convergence of digital and physical. One way to say this is that the internet is becoming Internet of Things, is entering in cities, in physical space, and is producing a huge amount of data. And data can help us then to better understand cities, to change the way we can comprehend them, design them, and ultimately live within them. And that's really what we try. Here we got many collaborations in the world. We think in order to innovate, it's very important to collaborate. Very happy that Senseable Lagos Lab will be the first lab outside of MIT in Africa. We got a base in Amsterdam, in Stockholm. We started a base in Singapore, but Lagos will be the first base in Africa. Thank you. And if you look at this, when you look at this picture, that's what it shows you. With data, we can look at the city in a way we couldn't just a few years ago. If you look at this, it's a city like a living organism. And again, it's through billions of data points we can collect in real time. In this case in particular, it's the city of Lisbon in Europe. What you see there is data from, let me restart the video. But you see it's a multi-mobility network. And again, this data can help us uncover dimensions. So we're looking at this in clearly solutions in different places are different. The solutions in New York are different. And so I will tell you again about mobility in Amsterdam. In this case, as you might know, Amsterdam is a very interesting city. When you look at the center of Amsterdam, there's not much asphalt, not many roads, but there's actually a lot of water. And so we just heard before about self-driving cars. Yes, self-driving cars might change mobility in a few years. But in the case of Amsterdam, we started working with the city and think about what about using the waterways in order to allow people to move and connect in a different way. And so we started developing kind of self-driving boats. We call them robots. Little boats that could help you to move things around. Today, the boat in Amsterdam to move people around. So to become a platform to better understand the environment, to move things, but also to sense water quality, air quality, and so on. And if you look at these, they can become also a way to create like a temporary infrastructure. Think about a temporary bridge when you need it because of a special event or because of some kind of concert, which, by the way, is something nothing new. The city of Venice.
This is Lucy. Lucy is a robot, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Robots offer a solution by to the water. From A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Robots are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Robot's onboard computer combines and processes all of the data and runs the robot software so it can successfully complete its mission plan. After 5 years of development, testing and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Robot is ready for the next step. Join us and let's unlock the potential of urban waterways together.
Thank you. Long time, during a special day called the Festa del Redentore, when all the gondolas come together and create a kind of temporary bridge. But today, again, sometimes technology is just a way to do what we've always done, or what we always wanted to do, but to do in a more seamless way. So I'll tell you briefly about what we've been doing with Amsterdam. These were the first linear boats we developed, very small, with different type of propulsion. This is 1 to 4, so scale model. These were being tested in the canals in Amsterdam just 3 years ago. We worked on this for 5 years with the city. Now it's becoming a company. Again, the interesting thing that's happening, a lot of this here in Lagos, but also as part of Tech Valley, the idea of turning research into innovation and into companies. So this was again being tested to see how flexible is the small boat. And I'll finish with the final project where we look at when you look at flows, you can look at many types of flows in the city, and certainly some important flows are related to waste. We usually don't think about waste. We look at products coming to our homes, but then when we start thinking about what happens, like that computer which is down there, and today we know everything about that machine until when it gets to our homes.